Hello students, through this video we are going to study the fifth unit of subject power system analysis, and title of the unit is unsymmetrical fault analysis. If we go through the contents of the fifth unit, that is unsymmetrical fault analysis, the contents are method of symmetrical components, relationship, sequence impedances, then a representation of the power system by positive, negative and zero sequence network, nature of sequence impedance of power system components, then line to line, line to ground, line to ground faults, and analysis of unloaded and preloaded alternators and simple power system with and without fault impedance. So before going to start this unit, in unit number 4, that is symmetrical fault analysis, we had discussed about what is meant by the fault in case of the power system, what are the different type of the faults in power system, then what is the difference between the symmetrical and unsymmetrical fault, and what is the purpose of the symmetrical fault analysis. So in that unit, in conclusion, we had discussed that in case of the symmetrical fault analysis, the main purpose of the symmetrical fault analysis is nothing but to identify or to find out the rating of the protective equipments, that is selection of the circuit breaker, selection of the current limiting reactor, and we had also discussed the different examples for the selection of circuit breaker and current limiting reactor. So before going to start this fifth unit, we'll just revise the basic concepts which is required to study this chapter. So first of all, what is meant by the fault in case of the power system? We are having the idea that fault is nothing but any abnormal condition which affects the stability of the power system, or which affects the normal operation of the power system. And if we want to define the fault, fault is nothing but fault in an electrical equipment or apparatus is defined as a defect in the electrical circuit due to which current is diverted from its intended path. Now, this current is diverted from its intended path because of the different reason. So, what are the causes of these failures? The first cause is nothing but breakdown may occur at normal voltages, and second, breakdown may cause due to the abnormal voltages. So if we consider the first case, breakdown may occur at normal voltages. The main reason are nothing but the first reason is the deterioration or aging of the insulation. That is, whenever the insulation get damaged, then the conductors of the two phases may come in contact with each other, or the conductor may come in contact with the ground, and there might be the failure may occur. And second reason, the damage is caused by the unpredictable happening, such as blowing of the heavy wind, tree falling across the line, vehicle colliding with the tower or poles, bird shorting of the lines, aircraft colliding with the lines, line breaks, etc. That is, these are the external reason or the mechanical reason because of which the breakdown may occur. And now, second reason, breakdown may cause due to the abnormal voltages, and it may be caused by the switching surges or lightning strokes, which may be either direct or induced. That means the breakdown may be occur at the normal voltages or abnormal voltages because of the different reason. Now, if we discuss about the approximate percentage of the various causes of the fault, till now we have discussed that there are the different reasons, but the mostly the faults occur because of the lightning are almost 12% of the total fault, whereas the fault occur because of the sleet, wind, mechanical reason like jumping conductor, it is 20% of the total fault. The fault occur because of the apparatus failure, is 20% of the total fault. Then fault because of the switching to a fault, it is 20% of the total fault. And miscellaneous reasons like tree falling on lines, bird, sabotage, accident, etc. is 28% of the total fault. Suppose the construction is going on, then during the digging work, the fault may be occur. So it also come under the category of miscellaneous. That means, in short, we can say that there are different reasons, but lightning, then sleet wind, mechanical conductor, apparatus failure, switching to a fault, these are the different major reasons for which causes the fault, and we have discussed what is their contribution in developing the fault. Now, if we discuss about the frequency of the fault occur in different link of the power system. Now, what is the meaning of link of the power system? We are having the idea that power system. What is meant by the power system? Power system is nothing but it is the arrangement of transmitting the power from generating station to the load, and that's why it consists of different part, like for generation there might be the generator used, then for the transmission of the power and distribution of the power, there might be use of the transmission line, then cables, transformer, switchgear and protective equipment, etc. And at the load side also we are using the different uh, load managing equipments. Now, how these different equipments which are usually in the different part of the power system contribute to the fault? If we go through the frequency of the fault, then overhead line causes almost 50% of the total fault. Then cables, in case of the cable, the fault may occur because of the insulation damage, and it contributes 10% of the total fault. Whereas the fault occurring on the transformer contribute 10% of the total fault. The fault because of the switchgear is almost 15% of the total fault. Then control equipment which are used to control the operation of the power system, they contribute 3% of the total fault. Then we are having the idea that instrument transformer, that is CTs and PTs, are used for the measurement as well as for protection purpose in case of the power system. They also contribute 2% of the total fault. And miscellaneous results, miscellaneous equipment, which are used in case of the power system, they contribute 10% of the total fault. That means from this slide, if we go through the frequency of the fault occurring in different link of the power system, conclusion is that the majority of the fault are contributed by the overhead lines, and hence the protection of the overhead line is also important point in case of the power system analysis. Now, if we are going to discuss about the different types of the fault in case of the power system, the main type of the fault are nothing but open circuit fault and short circuit fault. We are having the idea that whenever the conductor may get break at any point, then open circuit fault type of the fault is present. Whereas in case of the short circuit fault, the insulation may get damaged and conductor of different phases may come in contact with each other, or it may come in contact with the ground. Then short circuit type of the fault occur. But in this case, the chances of occurring of the open circuit fault are very less, because in this case it is similar to the permanent type of the fault, and it is mostly caused by the external reasons or mechanical reasons. Like suppose the construction is going on and digging work is going on, and because during that work, if the conductor may get open or falling of the trees on the line, it may break the conductor. In such case only there are chances of the open circuit fault. Whereas the short circuit fault are causes because of the insufficient or slow developing fault, and which may cause the permanent type of the fault. But these faults are more severe. That is, we can say that most common and dangerous faults are the short circuit or shunt fault, and hence while doing the fault analysis, mostly we focus on the short circuit type of the fault. Now, if we going to classify the different short circuit fault in case of the three-phase system, Then it is classified into the different type, and the first type is single phase to ground fault. So what happens in this case? In this case, the conductor of any phase, it get in contact with the ground, and such type of the fault is called as the single phase to ground fault, and it is represented by LG. Then another type of the fault is phase to phase fault. In this case, the insulation may get damaged, and because of that, the conductors of the two phases come in contact with each other, and it causes the abnormal condition. And such type of the fault is represented by L to L or L dash L type of the fault. Then another type is two phase to ground fault. So what happens in this case? In this case, the two conductor of two phases come in contact with each other, as well as they are in contact with the ground also. And such type of the fault is called as two phase to ground fault, which is represented by L dash L dash G or LLG type of the fault. Then next type of the fault is the combination of LG and double L type of the fault, that is phase to phase and third phase to ground fault. So what happened in this case? In this case, the two conductors of two phases come in contact with each other, as well as third phase is in contact with the ground. Then next type is all the three phases to ground. In this case, three conductors of three phases come in contact with each other, as well as it is in contact with the ground also. But chances of such type of the fault are very less. Then last type of the fault is all the three phase short circuited. That is, conductors of all the three phases are come in contact with each other, and it mostly occur because of the damage of the insulation between all the three phases. So these are the different type of the fault. Now these faults are again classified into the main two types, that is symmetrical fault and unsymmetrical fault. So what is meant by the symmetrical fault? In case of the symmetrical fault, the faults the phasor displacement of all the three phases are equal in magnitude. And if we want to define the symmetrical fault, the faults which are symmetrical in nature and gives rise to symmetrical current, such as equal fault current in the three phases with 120-degree displacement, are called as the symmetrical fault. So what are the example of the symmetrical fault? The first example is all the three phases to ground. That is triple LG fault, and it is occur due to the breakdown of insulation between all the three phases, as well as these conductors, open conductors, come in contact with the ground. And another example of the symmetrical fault is nothing but all the three phases short circuited. That is, whenever the insulation between all the three phases get damaged, at that time all the three phases are come in contact with each other, and this type of the fault is occur. So that means triple LG and triple L are the example of the symmetrical fault. Now, as the title of the fifth unit is unsymmetrical fault analysis, we should have the idea about what is meant by the unsymmetrical fault. So, as the name suggests, unsymmetrical, that means in this case the system is in unbalanced condition. And if we go through the definition, the faults which are unsymmetrical in nature and give rise to the unsymmetrical current, such as the different current in the different phases or three phases of the system, then it is called as the unsymmetrical fault. So what are the example of the unsymmetrical fault? First example is single phase to ground fault. That is LG type of the fault, and we know that it occurs whenever there is breakdown of insulation between one of the phases and earth. Then second example of the unsymmetrical fault is phase to phase, that is L-L or LL type of the fault, which occurs because of the insulation between damage of the insulation between the either of the two phases. That is, it may be between RY, YB or RB. Then two phase to ground fault, which is represented by LLG type of the fault, and it occurs because of the damage of the insulation between the two phases and ground. And last example of the unsymmetrical fault is nothing but phase to phase and third phase to ground. That is, it is the combination of the LG and LL type of the fault, and it mostly occur whenever the insulation between the two phases get damaged, as well as the because of the damage of the insulation, the conductor of the third phase is come in contact with the ground. So in short, we can say that the LG, double L, double LG, then phase to phase and third phase to ground are the example of the unsymmetrical fault. Now, since we are going to study the unsymmetrical fault analysis, first of all, we should have the idea about what is the purpose of the unsymmetrical fault analysis. So, during the last lecture, we had discussed about the purpose of the symmetrical fault analysis. The purpose of the symmetrical fault analysis is nothing but selection of the circuit breaker, current limiting reactor, or we can say that the selection of the protective equipment. Now, in case of the unsymmetrical fault analysis, major of the faults occur in case of the power system and unsymmetrical fault, and it becomes necessary for engineer to calculate the fault current in such condition. The information obtained is necessary for the determination of the protective gear relay setting and studies of transient stability in interconnected power system. So what is meant by the transient stability? That point actually we will study in the last unit, that is power system stability. In power system, the stability is classified into the steady state stability, transient stability and dynamic stability. But the main purpose of the unsymmetrical fault analysis is nothing but but to study the transient stability in case of the power system. Now, not only it is essential to calculate the current at the fault, but also how it is distributed and in what magnitude throughout the network behind the fault. So that is, we use the unsymmetrical fault analysis for the calculation of the fault current as well as its distribution. Then a fault study also involves the unsymmetrical voltages which arises a knowledge of which is essential in protective system of the directional type where the voltage element is important. For unsymmetrical fault, simple single phase representation is not valid and analysis has to be carried out on three-phase basis. That is, for the since the unsymmetrical fault causes the system in unbalanced condition. So for what is the actually procedure? We convert this unbalanced system into the balanced one by using the different methods. So for the analysis of the unsymmetrical fault condition may alternatively be carried out using the method of symmetrical components. And method of symmetrical component is the means by which an unbalanced three-phase system of impedances may be resolved into the three equivalent single-phase system having the independent impedance parameters. The three impedance system may be suitably connected and constrained to represent all type of the fault condition. That is, by using the method of symmetrical component, we represent the different type like line to ground fault, then line to line to ground fault, etc. And symmetrical component method is simpler, having accurate result for the most purposes and provide the useful analytical tool for protective engineer. So by the conclusion of this slide is nothing but for the since unsymmetrical fault causes the system in unbalanced condition, and that's why there is a need to do the unsymmetrical fault analysis. The purpose of the unsymmetrical fault analysis is not only to calculate the fault current but also to decide the protective gear relay setting and for study of the transient stability. But since this system is unbalanced, for analysis purpose, it is converted into the balanced one, and that method is called as the method of symmetrical component. Once we do the analysis in balanced condition, then again all the parameters are converted into the original or actual form. So, what is meant by the methods of symmetrical component? The method of symmetrical component is very powerful approach and has simplified the procedure for solving problem of unbalanced polyphase system. This method is valid for any number of phases, but the three-phase system is of main interest. And the method of symmetrical component was proposed by C.L. Fortescue in the year 1948. So what we do in this case, what is if we think about what is meant by the symmetrical component, according to the Fortescue theorem, any unbalanced three-phase system of current, voltages of other sinusoidal quantities can be resolved into the three balanced system of phasors, which are called as the symmetrical component of the original unbalanced system. Such three balanced systems contribute the three sequence network which are solved separately on a single phase basis. Once the problem is solved in terms of the symmetrical component, it can be transferred back to the actual circuit condition by superposition or phasor additions of the sequence quantities, that is current or voltages easily. So what is meant by the symmetrical component? Then what is meant by the sequence impedances, and the remaining point of this unit will be discussed in the next lecture. Thank you.